Assalamualaikum friends, this is Mohammad Inam, and in this video I am going to teach you how to find this complicated Laplace inverse problem. Often this type of problems occur in research areas. So for more interesting videos, kindly subscribe my channel. Okay friends, let's try to solve this one by using a simple technique, which is Heaviside expansion technique. I've already teach this technique in my last video. If you don't know about this technique, so review my last video. Solution. Heaviside expansion technique tells us that Laplace inverse of f bar of s divided by g bar of s equals to summation I equals to 1 up to n f bar of alpha I divided by g bar prime of alpha I e power alpha I t, where alpha I are the roots of g bar of s. Let's say this is f bar of s and this is g bar of s. For the roots of g bar of s, we know that sine hyperbolic of x equals to e power x minus e power minus x divided by 2. So this information, this will be e power x square root of s minus e power minus x square root of s divided by 2 whole divided by e power l square root of s minus e power minus l square root of s divided by 2. So 2 and 2 will be cancelled. Now we will equate this part equals to 0 for alpha I. We will get e power l square root of s minus e power minus l square root of s equals to 0. Adding both sides e power minus l square root of s, we will get e power l square root of s equals to e power minus l square root of s. Dividing both sides by e power minus l square root of s, we will have e power 2l square root of s equals to 0. If e power 2l square root of s equals to e power 0 equals to 1. So equating power, we will have 2l square root of s equals to 0, implies that s equals to 0. One singular point or 1 alpha I and other roots are e power 2l square root of s equals to e power 2n pi iota equals to 1. So equating power, 2l square root of s equals to 2n pi iota, dividing by 2 square root of s equals to n pi iota over l. Squaring both sides, so we will have s equals to minus n square pi square over l square. Let's say this is Sn, series of roots. So we have two singular points. One is singular 0 and other one is series. Now try to compute this result. Next step will be, we have to compute g prime. If sine hyperbolic of l radical is equals to g bar of s, then g bar prime of s equals to l over 2 square root of s cosine hyperbolic of l square root of s. You can find this by easily chain rule. Now we have to compute this result, or I can simplify. At s equals to 0, this will be 2 square root of s over L sine hyperbolic of x square root of s divided by cosine hyperbolic of L square root of s e power alpha t. S equals to 0 means alpha equals to 0. If I am going to put this s equals to 0, then this term whole will be 0. So at s equals to 0 we find 0. Now we have to compute this result at s equals to Sn at series. Then this result will be 2 square root of Sn sine hyperbolic x square root of Sn L cosine hyperbolic L radical Sn e power Sn t. We have to compute this result and we will done. I am simplifying here. Radical Sn equals to radical minus n square pi square over L square equals to n pi iota over L. So this will be 2n pi iota over L. This L and this L will be L square sine hyperbolic x n pi iota over L cosine hyperbolic n pi iota over L e power minus n square pi square over L square times t. This L, this n will be going to cancel out. From basic calculus we know that sine hyperbolic iota x equals to iota sine x and cosine hyperbolic of iota x equals to cosine x. We will put this result here, so we'll have 2n pi iota and this will be iota sine x n pi over L divided by L square cosine n pi e power minus n pi over L whole square times t. This iota and this iota will be minus 1. 2n pi L square cosine n pi sine n pi x over L e power minus n pi over L whole square times t. Now cosine n pi equals to 1 and minus 1. If n equals to 1, then this will be minus 1, n equals to 2, this will be 1. So we can simplify this result and say that minus 1 power n plus 1 2n pi over L square sine n pi x over L times e power minus n pi L whole square times t. Through the theorem statement, this will be Laplace inverse of the sine hyperbolic x square root of s divided by sine hyperbolic L square root of s equals to 2 pi over L square times summation I equals to 1 up to n minus 1 power n plus 1 times n sine n pi x over L times e power minus n pi L whole square times t. This is the Laplace inverse of the above function. So we have done. You have seen, guys, that how I computed this complicated Laplace inverse in simple manners. If you like the video, then subscribe my channel. Thank you.